Welcome to Biology My Passion. I am Soumya Harikrishna. Today we will do some numericals from the chapter Electricity. First question goes like this. Conducting wire carries 10 to the power of 21 electrons in 4 minutes. What is the current flowing through the wire? So what are we supposed to find out? We have to find out current I. We know that I can be found out by the formula I is equal to Q upon T. But what is given here? 10 to the power of 21 electrons. So N is equal to 10 to the power of 21. That is number of electrons. And time is also given. 4 minutes means what? 4 into 60 seconds. If any unit is not in SI unit, we have to immediately convert it into SI unit. Then find the current. So from N and E, we can find out the Q. So Q is equal to NE. N is the number of electrons 10 to the power of 21 into E is the charge of 1 electron 1.6 into 10 to the power of minus 19 coulomb. So here the answer would be 1.6 into minus 19 and plus 21. What will you get? 10 to the power of 2. So multiplying by 100, that is 160 coulomb. Now I is equal to Q upon T, that is 160 upon 4 into 60. 4 times, right? So 4 by 6, that is 2 by 3 is equal to 0.66 ampere. An electric toaster has a power rating of 200 watts, that is power, operates for 1 hour in the morning and 1 hour in the evening. So time is given. How much does it cost to operate the toaster for 10 days at ₹5 per kilowatt hour? These type of questions are very common. So in such questions we are supposed to find out energy. So what is the formula for energy? Energy is equal to power into time. But here we are finding out in kilowatt hour. So power we have to find out in kilowatts. So 200 watts is the power. So we can make it as 200 by 1000 kilowatt. So now for finding energy, we just have to multiply all. 0.2 kilowatt hour of power is used for 2 hours. Time is taken in hour itself because we are using kilowatt hour. And how many days? 10 days. So this will give us total energy, that is 20 into 240, 4 kilowatt hour. So for 1 kilowatt hour it is the 5 rupees you have to pay. So the total cost would be 4 into 5 rupees 20. So for 10 days how much they have to pay? 20 rupees. An electric oven of 2 kilowatt, here power is given in kilowatt, rating is operated in a domestic electric circuit 220 volt that has a current rating of 5 ampere. What result do you expect? Explain. So here power is given, that is 2 kilowatt, and voltage or potential difference is 220 volt. Current rating is 5 ampere. So the rating in the appliance given is 5 ampere, or the appliance can work under 5 ampere. But we are providing a potential difference of 20 volt and power is 2 kilowatt. So actual current we have to find out. So I is equal to P by V. Why? Because we know that P is equal to VI. So I will be P by V. So what is it? 2 kilowatt by 220. So here 2 kilowatt we will make it into watts into 1000. Okay, by 220 volts. So in this case we will get the current as 9.1 ampere. So 9.1 ampere of current is coming into the gadget. But what is the rating? Only 5 ampere. So what happens? The gadget will get damaged. Or if there is a fuse wire will melt. In which way fuse wire is connected? Series. Fuse wire is always connected to the circuit in series. So if there is no fuse wire, the damage will occur to the appliance. At the same time, if there is a fuse wire, it will protect the appliance by melting itself. Two lamps, one rated 100 watts 200 volt and the other 60 watt 200 volt are connected in parallel to electric main supply. Find the current drawn by the two bulbs from the line if we supply voltage is 220 volts. So we have to find out the current separately. So current in the first gadget, lamp 1. We know the formula P is equal to VI. So we are finding out I is equal to P upon V. So what is it? First one is 100 watt by 220 volt. The lamp 2, again P is equal to VI. Here I is equal to P by V. What is P? 60 watts by 220 volt. 3 by 11, 0.27. Which of the following is true about point P? So here there is a point P and we know this is the battery, this is the positive charge, negative charge. So the current is flowing like this. So we have to take the flow of electrons in the opposite direction. Current is flowing in direction 4. So this is 4, that is wrong because it is not going to 4. Electrons is flowing in direction 4. That is correct because flow of electrons is in the opposite direction of current. So in this case, yes, it is flowing in 4th direction. Electrons is flowing on either direction 1 or direction 3. No. Electron is flowing in direction 2. No, that is the flow of current. So here the answer is option D. Voltage current VI graph of a metallic conductor at two different temperatures T1 and T2 are given here. So in this graph you can see T2, T1, these are two temperatures and V is in this pole and I is in this axis. We know that when temperature increases, resistance also will increase. So this will have high resistance and this will have less resistance. This is high, this is low. So we know that in a VI graph, whenever we are plotting, the line which is closer to the VI graph, V axis, will be having high resistance because V by I is the resistance value, and when it is closer to V means slope of the graph will be very high. So in this case T2 will be the highest. Electrical refrigerator rated 400 watts operates 8 hours a day. The cost of electrical energy is rupees 5 per kilowatt hour. Find the cost of running the refrigerator for 1 day. So here again energy we are supposed to find out P into T. So what is power? 400 watts. Immediately you have to convert it into kilowatt because in domestic circuits we are using only kilowatt. So by 1000 kilowatt. Time in hours only 8 hours. The cost of electrical energy rupees 5 per kilowatt hour. So energy is equal to 400 by 1000 into 8. So we will get 32 by 10, 3.2 kilowatt hour is the current. So cost will be, it is 1 day. So 3.2 into rupees 5 per kilowatt hour. So 60 rupees. Rupees 60. For the second part, calculate the energy transformed by a 5 ampere current. So I is equal to 5 ampere flowing through a resistor of 2 ohm. R is equal to 2 ohm for 30 minutes. Time is equal to 30 into 60. Minutes is given, so we convert it into second. Energy we have to find out again. HE is equal to P into T. Use the formula I square RT, because P is equal to I square R, right? We can write P because I we know, R we know, so P is equal to I square R, so I square RT. 5 square into 2 into 30 into 60. So 25 into 2, 50 into 30 into 60. 90,000 joule. So 90,000 joule can be 90 kilojoule we can write. So this is B part. Now what is C? Difference between kilowatt and a kilowatt hour. Kilowatt is the unit of power. Whereas kilowatt hour is the unit of energy. That's the difference. Okay. Now convert 250 kilowatt hour into energy. How to convert kilowatt hour into energy? 1 kilowatt hour is equal to how many joules? 3.6 into 10 to the power of 6 joules. Therefore, 250 kilowatt hour is equal to 3.6 into 250 into 10 to the power of 6. So from here 10 we are taking out to make it into 36. 36 into 250 into 10 to the power of 5. So we will multiply 36 and 25. So this can be written as 9 into 10 to the power of 3 into 10 to the power of 5. So what is the answer? 9 into 10 to the power of 8 joules. A piece of wire having resistance R is cut into 4 equal parts. So each part will be having R by 4 resistance, because it was a total wire. It is cut into each half will have R by 4. So how does the resistance of each part compare with the original resistance? So it will be compared to original resistance 1/4 of the original resistance. Then if 4 parts are placed in parallel, how will the resistance of the combination in comparison with the resistance of the original wire? So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. 4 pieces are there. Each one is R by 4. So we can take the reciprocal 4 by R plus 4 by R plus 4 by R plus 4 by R. So it is 16 by R. So Rp is R by 16. This is how we can connect them, are 4 parallel ones, each one having R by 4 ohm. What is the effective resistance between points P and Q in the circuit shown below? Here you can see, suppose if you take this is P, this is Q, these two are in series. These two are in series and this is in the center. So if I redraw, I can draw like this. This is P, this is Q, all 3 ohm. Okay. So if I take again 3 and 3, what will I get? 6 ohm, 3 ohm, 6 ohm. Okay. So usually how will we calculate? 1 by 6 plus 1 by 3 plus 1 by 6. But there is a shortcut here. Whenever two equal resistances are in parallel, the total resistance will be half of it. So 6 and 6, how much we will get? 6 and 6 together we will get 3 ohm. Then 3 and 3 together we will get 1.5 ohm. So total we have 1.5. So any two parallel connection, same resistance, the answer would be half of it. If in figure R1 10 ohm, R2 40 ohms, R3 30 ohms, R4 20 ohms, R5 60 ohms. Calculate, connected to the arrangement, calculate total resistance. So we know that these three are parallel, these two are parallel, and these two are in series. So R1 is parallel to R2. Therefore 1 by Rp is equal to 1 by 10 plus 1 by 40. So 4 plus 1, 5 by 40. Therefore Rp is equal to 8, 40 by 5. Now the second combination, 1 by 30 plus 1 by 20 plus 1 by 60. These three are parallel. So total resistance 1 by Rp will be, 60 is the LCM, 2 plus 3 plus 1. So 6 by 60. So it will be 60 by 6, so that is 10 ohm. Now these two are in series, so Rs is equal to 8 ohm plus 10 ohm, 18 ohm. So the total resistance will be 18 ohm. But they are asking total current flowing in the circuit. Battery is 12 volt. So we know that I is equal to V upon R. V is 12 volt by 18 ohm. So we know that this will go as a 4 by 6. So 2 by 3, again 0.7 ampere. This is the minimum resistance which can be made using 4 ohm resistors. So minimum, whenever you want to get, you have to connect in parallel. And maximum, if you want to get, you have to connect them in series. So here we want minimum 4 resistance with a 4 ohm. So 1 by Rp is equal to 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 is equal to 4 upon 4. Rp is equal to 1 ohm. So answer A. The following table gives value of resistivity of some materials. We know resistivity is the characteristic of a particular metal. The resistivity of these materials are: A has 44 into 10 to the power of minus 6, B has 10 to the power of 10 to 10 to the power of 12, 1.6 into 10 to the power of minus 6, 10 to the power of 15 to 10 to the power of 17. Which material would you suggest to be used in electric heating devices? Give reason. So as material used in electric heating devices are generally made up of alloys, because they have high resistivity in the range of 10 to the power of 8 to 10 to the power of minus 6 ohm meter. Material A will be used for, this is in that range, right? 10 to the power of 8, minus 8 to 10 to the power of minus 6. So that is, here it is coming in that range. So here A and C both have 10 to the power of minus 6, but this is the highest value. So heating devices, its resistivity is very high compared to C, which is a metal. B and D are insulators because their resistivity is very, very high. On what factors does the resistance of a conductor depend? The resistance of a conductor depends on the following factors. First, length of the conductor. We know resistance is directly proportional to length. Area of cross section, resistance is inversely proportional to area. Nature of the material of the conductor, that resistivity, okay, and higher the resistivity, higher the resistance also. Then temperature of the conductor. Temperature increases, resistance will also increase. Calculate the resistance of an aluminium cable of length 10 km. 10 km in meter will be 10,000 meters. Diameter 2 millimeter. 2 millimeter. Now let us find out the resistance. Resistance can be found out using the formula rho into L upon A. So here length is given as 10 km. 10 km is converted into SI unit 10,000 meter, or we can write 1 into 10 raised to 4. Then diameter is 2 millimeter. 1 millimeter is 1 by 1000 meter. So we can write it as 2 into 10 raised to minus 3. But we have to find out R from that. So half of diameter is R. Why are we finding out R here? Because area is not given. We have to find out area using the formula pi R square. Rho is given 2.7 into 10 raised to minus 8 ohm meter. Now if you write R is equal to rho 2.7 into 10 raised to minus 8 into length is 1 into 10 raised to 4 meter divided by pi 22 by 7 into diameter divided by 2, that you will get 1 into 10 raised to minus 3 square. So if you bring this 7 to the numerator, 2.7 into 7, and this 10 raised to minus 8 and 10 raised to 4, we will get 10 to the power of minus 4. Below we have 22 in the denominator, and this 10 raised to minus 3 and 2 will get 10 raised to minus 6. Now here this 10 raised to minus 6 we are taking to the numerator, so it becomes 10 raised to 6. So 10 raised to 6 and 10 raised to minus 4, what will you get? 10 raised to 2 or 100. So we are multiplying 2.7 into 7, that into 100 you will get 1890 upon 22. So that value if you solve you will get 85.9, we round off to 86 ohm. These types of questions you have to be careful about the exponents you are taking and their sign. Here we have a combination of resistors. In the equivalent resistance between M and N we have to find out. So here we know that R3 and R4 are parallel. The other two are in series to that. So first we will find out the effective resistance between R3 and R4 which are parallel. So 1 by Rp is equal to 1 by R3 plus 1 by R4. But here we don't have any value. So we know that LCM can be taken as R3 into R4. On top, by dividing with LCM we will get R4 plus R3. Right? So now we are finding out Rp will be reciprocal of this, that is R3 into R4 upon R4 plus R3. That is Rs now R1 plus R2 plus R3 R4 upon R4 plus R3. Series means we are adding all these values together. Now next is state Joule's law of heating. What is Joule's law of heating? H is equal to I square RT. That is heat produced is directly proportional to the square of the current. Heat produced is directly proportional to the resistance, and it is also directly proportional to time. That is Joule's law of heating. Why we need a 5 ampere fuse for an electric iron which consumes 1 kilowatt of power in 220 volt. So power 1 kilowatt is 1000 watts, volt is 220 volt. The current required for the iron to work will be 4.5 ampere. So if you use a fuse below that, the gadget will not work. So next higher value is 5 ampere fuse. So we have to use a 5 ampere fuse. So if there is any undue flow of electric current through it, the fuse will melt, saving the iron from getting damaged. We have one last question from energy. In a house, 3 bulbs of 100 watts each are lighted for 5 hours daily. 2 fans of 50 watt each are used for 10 hours daily. Electric heater of 1 kilowatt was used for half an hour daily. Find the total energy consumed in a month of 31 days and its total cost at the rate of rupees 3.6 for 1 kilowatt hour. So we are paying for the energy used in kilowatt hour. So first you have to find out what is the energy used by bulb, then fan, then heater. Add these three, total energy into 31 days into 3.6. Okay. So let's see energy used by bulb. Power is 100 watts. That means 100 by 1000 kilowatts, right? Time five hours. So energy is P into T. 0.1 into 5. 0.5 kilowatt hour. That is bulb. 3 bulbs are there. So 0.5 into 3, 1.5 kilowatt hour. Now coming to fan. Power is 50 by 100,000. So here it is 0.05 kilowatt. Then energy will be 0.05 into how many hours? 10 hours daily, right? Into 2 fans. So total energy will be 1 kilowatt hour. Then heater already given in kilowatt hour. 1 kilowatt hour into half an hour. So 1 by 2, 0.5 kilowatt hour. So total energy is equal to 1.5 plus 1 plus 0.5. 3 into 31 into 3.6 will be the cost. So it will be 334.8 rupees. Hope you understood all the numericals. We covered almost all type of numericals, including power, heating effect, Joule's law of heating, and finding out the current, finding out the potential, the total resistance in a circuit, questions with the resistivity. So all these types of problems you keep practicing. If you have any doubt, just comment in the comment box. Okay. So thank you for watching Biology My Passion. Like, share and subscribe to my channel Biology My Passion.